All right, so we're doing inverse functions today. All right, so we need to first define what an inverse is. So an inverse can be found a few different ways. It can either be found by reflection over the line y equals x. If you have a table, you'll find an inverse by switching x and y for those coordinates. And if it's an equation, you're going to do the same thing. We're going to switch x and y and solve for the new y. Okay? Do you need a new pencil? All right, can I scroll a little bit? Guys? Yeah. Okay. All right, so that's the remainder of the definition of an inverse. Fine, except my husband was all cranky because the Buckeyes lost. All right, can I scroll past like the first two bullets under inverse? All right, so here's the definition of one-to-one. One-to-one is a special subset of functions where for every one x, there's only one distinct y, but the opposite is also true. So for every one y, there's only one distinct x. So this means it needs to pass the vertical and the horizontal line test. So quadratics are not one-to-one. Absolute value functions are not one-to-one. Anything that has two sides to it, basically, not one-to-one. All right, did anybody else have the Ohio State sheet thingy that they need to get turned in? I think I have it in the grade book as being due tomorrow. All right. We're ready to start actually solving these? All right. So, wrong button. All right. So here's our first two examples. And algebraically seems to be the most difficult way for students to do it, simply because you have to get it back to y equals again. All right. Ready? So, when we go through to do these, first step is always write it in y equals form. All right. I know that seems stupid and it seems tedious, but it does help when it comes down to making sure you're setting stuff up right. Second step, switch x and y. All right. Third step, solve for the new y. All right. So I need to get y by itself, move the 2. So x minus 2 equals 3y. Divide both sides by 3, and I get y prime equals x minus 2 over 3. And you can rewrite this as x. Hang on. Can't talk and work at the same time. It's f with a negative 1 for an exponent. That is the mathematical way of saying inverse. And you can just leave it as the whole quantity x minus 2 divided by 3. If you really want, you can split it, but meh. You guys want to try number 2 with your neighbors? Sure? Right here. So that negative 1 is how we mathematically denote inverse. Okay, so if you think in terms of a fraction, you'll have 2/3. If you take 2/3 and raise it to a negative 1 for an exponent, it flips it. So it becomes 3 over 2. So some old dead dude has decided we're going to keep using that symbol to mean inverse for a function. All right. All right, do you guys need a awkward question of the day? Okay. Where was it? I just had it. If you were at a funeral and the body fell out of the casket, what would you do? Share it with your neighbors. Oh, it's squared. It's Monday. All right, so general consensus of body falling out of the casket is we're just going to laugh. Yes? All right, how did example 2 go? Still got to write stuff down, bud. Yes. You need to show your work. Okay. All right, so if you have a 6-point problem on a test and you show me no work but you get the wrong answer, I take off 6 points. If you show me the work and I can figure out that you wrote 2 plus 2 is 5, I only take 1 point. Honey, they're simple now because it's September. Just get in the habit of doing it. I know, I'm ruining your life. All right, you want to try example 3? Thanks. Hang on, I'm recording. Yeah, this is the proper math. This is the notation. No, I just always like having students know that that is what that means. Because, like, the next problem says, tell me if the 2 given functions are inverses. So you'll see that notation. All right, ready? All right, so next 2 is state if the given functions are inverses. So what do you guys think you want to do? Just found the inverse for 1 to see if it gives you the other function? Heck yeah. That is a valid method. Which one do you think is easier? F of x or g of x? Yeah, because there's no fractions involved, right? This is an award for one of the math teachers who fixed the math lab sign-in. And then other classes requested I make little cups to go in the holes so they can put all their multicolored pens in them. So I printed those this weekend too. What? They have them in the library too. There's 3 of them. Yeah, they're for free in the library. Yeah, like the library right here. She's got 3 of them. I already printed Walter a friend. I did. I printed Kevin. So what do we think? Are those the same thing? Functionally, yes. Okay, I can split this and divide each of them by that negative 3. So that would give me f inverse of x equals negative 1 over 3x, and then negative 7 divided by negative 3 is plus 7 over 3. So they are the same, just different formatting. All right, I think I've got one more. Let's take a peek. Did I hear wait? Okay. We good? So, come on. You can do it, you stupid thing. All right, so here's the last one. All right, and I have these printed. Would you pass these out and I'll grab tape? All right, tape incoming. It is regular tape. I'm going this way. Google Classroom. You just upload it. Yeah, I can't keep up with 140 kids and who's turning it on paper and who's turning it in school. And so I just went with everybody turns it in online. Maybe once stuff settles down. You also need to pass the rest of the graphs down for your other people. Alex. Brett. Nope. Alright. So when it comes to, yoo-hoo, guys, when it comes to sketching the graph of the inverse, I always like to find a couple of the points on there first, because it does make actually going through and finding the inverse much easier. So when you go to do this, I've got a point down here, and this is what, 0, negative 4? And then I've got one here, and that's 1, negative 1. Another one over here at negative 1, negative 1. And those are about the best I've got. Okay? So remember, when you go to graph the inverse, you're just switching the x and y coordinates. I mean, if you want, you could draw the line and try to reflect it over, but I always find inversing my points makes life a heck of a lot easier. So the inverse of 0, negative 4 would be what? Negative 4, 0. 1, 2, 3, 4, 0. All right. Negative 1, negative 1. Does anything change on that? No. The other one is now going to be negative 1, 1. That's up here. And then, see if I can do this. Something like that. That's it. Bueno? Heard someone say that they were super confused. Is it about switching the coordinates? So remember, your big thing when you're looking at a graph is you're trying to reflect over the line y equals x. So y equals x goes through the origin, and it goes up like this, and then goes down like this. Something like that, right? But when I look at this, if I try to reflect it over, to me that's a little bit more difficult. So I would count down and over 2, and then I would have to go from the same point here and count 2 and up 2. That's, like, my brain can't compute. So that's why I write the actual coordinates, and then I flip them in my head. So I make sure I go through them that way. All right. Bueno?